guys, you finally made it. Welcome to the DHBW Smart Rollerz, the Carolo-Cup team of the DHBW Stuttgart. Currently, we are 17 active students from the faculties of Electrical Engineering, Computer Science and Industrial Engineering. This year, we participate in the Cup for the second time. But now, let's take a closer look at the test track and the car's parking lot. Normally, we would have built the vehicle from scratch here in the last 4 months. And as you can see, there are the testing places, and here are the working places for electronics and mechanics. But due to Corona, it was unfortunately not possible for us to work here. Therefore, all the components, hardware as well as software, are created at home, and we just came back here in the last 2 weeks to assemble all the components and to test the vehicle. Because everyone was working at home, the management of orders and existing materials was a very big challenge for us this year. However, let's finally start with the dynamic disciplines. The start procedure is initiated by the state machine and subsequently the vehicle drives off. For steering, trajectories must be determined by the lane detection system and transmitted to the lateral control unit. This information is then processed and the steering command is sent to the servo. In this discipline, lane detection is especially important. To prevent reflections, there's a polarizing filter in front of the monochrome camera. The recognized curves are then processed again as trajectories by the control unit. We use the Stanley control algorithm to control our servo. Our lane detection requires only one lane to reliably determine a trajectory. Multiple lanes make the algorithm more robust. Unfortunately, the overtaking process in the curve did not work out. The algorithm must therefore be validated in further tests in order to perform a safe overtaking process. The intersection detection runs as follows. Regions of interest are defined on the preprocessed bird's-eye binary images. In these, the HUF algorithm determines possible intersection lines, which are subsequently validated and used as a basis for decision making. A LiDAR is planned for the detection of objects in the next generation of the vehicle. Because of time constraints, we were not able to implement the algorithm and the LiDAR in a proper way. Due to the limited time available, we had to set priorities during the development phase. Since parking is optional in the normal basic cup, we decided to implement the algorithm for the next cup. Let's start with the question, how do we document a problem? First of all, test cases are defined for each requirement from the set of rules. These can be partially combined so that several test cases can be checked during one test. A test protocol is created for each test. As an example, the protocol is shown with the sample test from the task description. If the test fails, then an error message is created. In the error message, the error is prioritized and classified. Shown on the right, the error message associated with the test protocol. Since it is our second year in the Cup and there has been nearly no documented testing during the last season, we do not have the possibility of searching for similar solutions. At the moment, most knowledge transfer is through direct contact with the alumni. But what is the process for resolving the problem and how is it monitored? We have 3 categories in our testing folder directory. In the first directory, the detected error messages and protocols are stored. If the errors are corrected, the protocols and the error messages are moved to the second directory. At this step, the error message is supplemented with information about the source of the error and its cause by the responsible team. To be relocated to the third directory, the improvements must be confirmed by a test. If the test fails, the whole procedure starts again. This directory then contains the problems that have been solved and implemented, as well as tested for functionality. The testing results and the current status are discussed at least once a week in the team meeting. In case of high urgency, communication takes place directly between the teams involved.